Hello everyone, welcome to our first lesson from Chapter 8, Circumference. In Chapter 8 we're going to be measuring different figures. We will continue to address the question, how do measurements help you describe real-world objects? And our vocabulary will be circle, center, circumference, diameter, radius, and pi. This is the symbol for pi. As you can see, we've been given a circle and with a point right in the middle. So what is a circle? A circle is the set of all points in a plane that are the same distance from a point called the center. So it's a set of points. So we don't see this as a line, we see this as a set of points all tightly together. We call this the circumference, which is really what we call the perimeter of other shapes. But for a circle, we call the circumference. A way I like to remember is that the word circle and circumference both start with C-I-R, like circle, circumference. Is the distance around the circle, right here. This is the circumference. The diameter is the distance across its circle. So here we have the circumference all the way here, and then we have the diameter is the distance across a circle in its center. So this all the way through like this is the diameter. I like to remember the word diameter because it's di, and di is the distance across. So diameter is the distance, diameter. And the radius is the distance from the center to any point on the circle. So the distance from the center out to the circle. It could be at any point, any of these places. Okay, that would be the diameter. So it's the distance from the middle out, or really half the circle, half the distance. So the radius is half of the diameter. The diameter would go all the way across like this. Well, the radius is only this part. Make sure to have this diagram completed in your workbooks. A quick side note about our symbol pi. This is pi. Pi equals 3.14 when rounded to the 100th decimal place. Okay? What is pi? How does it relate to circle? Well, if I take the diameter of a circle and I measure directly across, okay, from end to end, I measure this length in centimeters, and I multiply by 3.14, I will get my circumference. Or the other way around, if I were to go backwards. If I know the circumference of a circle and I divide it by 3.14, I will get the diameter of the circle. Real world link. The table shows the approximate measurement of two sizes of hula hoops, so circles, right? A child hula hoop has a radius, remember only half the circle, only the distance half from the center point of the circle to the outer part of the circle, of 14. A diameter of 28 inches. Notice how the diameter is double the radius, because the radius only goes halfway through the circle while the diameter goes the full distance across the circle. Okay, that's the relationship between radius and diameter. For an adult, the radius, only half the circle is 20, so the full distance across the circle is 40. And the circumference, remember circle, the word circle, circumference, the distance around the circle is 88 inches, and here it's 126 inches. This is where pi, to go from this diameter to the circumference, this is where pi takes place. If I were to multiply 28 times 3.14, which is our pi, it's our value for pi, we would get 87.92, which rounded would be 88 inches. And same goes here. If I were to multiply 40 times 3.14, I believe you get about 125.6 or decimal 5, which rounds to 126. So you can see the relationship between the diameter and the circumference is linked to pi. A. Describe the relationship between the diameter and the radius of each hula hoop. Make sure to have this written down. So what is the relationship between the diameter and the radius? The radius is half of the diameter. Or you can say the diameter is double the radius. Describe the relationship between the circumference and the diameter. The circumference and the diameter of each hula hoop. The circumference is about 3 times longer. The circumference is about 3 times longer, slightly over 3 times over, because we have the decimal 1/4. Make sure you have these statements written down. So to quickly review radius and diameter, the diameter, d, of a circle is twice its radius, r. So diameter is twice the length of radius. The radius, or you could say it like this too, the radius r of a circle is half of its diameter, d. So symbols could be, if your diameter equals 2 times the radius. So let's just say my diameter is a, it would equal 2 times my radius, 4. Do you see that? Or if my radius is 4, it would equal, okay, a divided by 2. Okay, so the diameter of a circle is 14 inches. You see that? What would be the radius? So the radius would be half, right? If we're looking for the radius, find the radius. It would be half. So half of 14 is 7. But how would we do it mathematically? Well, we have to replace our variables. Radius is what we're looking for, and it's distance divided by 2, or diameter divided by 2. So my diameter is 14, so I replace the variable, and I divide it by 2, and there it is. The radius is 7 inches. Example 2. The radius, now we're being given the radius, of a circle is 8. Find the diameter. So remember, the diameter is double the distance of the radius. So we have a radius here, 8 feet. So our equation or our formula would be diameter is 2 times the radius. So we replace the variable. Diameter is 2 times 8. Diameter is 16. The diameter is 16 feet. If you think you got it, go ahead and try A to D on your own. Remember to use the formula for multiplication and division. Go ahead, pause the video now. So we're being asked to find the radius or the diameter. Here we're given the diameter, so clearly we're going to look for the radius. And the radius is half the diameter. So radius for A, this is question A, radius equals diameter divided by 2. So you go ahead and you replace your variable diameter with 23, so there it is. Now divide 23 divided by 2, and 23 is not a number divisible by 2, but 22 is, and 22 divided by 2 is 11, and 1 divided by 2, the other one that I have left to go from 22 to 23, is half, 0.5, so it's 11.5. Remember, the other way to do it is converting this to a mixed number. Okay, this improper fraction to a mixed number. How many 2's are in 23? You have 11 of them, right? 11 of them. What do you have left over? You have 1 left over, 2. So it's 11.5. For B, we're given the radius, so we're looking for the diameter. So we're going to use the diameter equation, where diameter equals 2 times the radius. So we replace the r with our 3, which is our radius. Radius is 3, so let's replace the radius with 3. And we get diameter equals 6 inches, correct? Right there, inches. For question C, we're given the diameter again, so it means we're looking for the radius. So the radius equals diameter divided by 2 applies again. But so let's just change this one to C over here, because we had A. And let's replace the variable. Okay, so radius equals 16 divided by 2, because it's 16, our diameter is 16, diameter is 16. And radius equals 8. 16 divided by 2 is 8. 8 what? 8 yards, right? So let's include our units. And for D, we're given the radius of 5.2, so we're looking for the diameter. Diameter is double the radius, right? We multiply the radius times 2. Replace the variable. So we take our radius right there and we replace this variable right here, okay? And 2 times 5 is 10 and 2 times 2 is 4. So it's going to be diameter equals 10.4 units. We're not given a unit, so we leave it at that. Now let's talk about the relationship between the distance across the circle, which we call that diameter, distance, diameter, and the circle, right? The circular shape, which is the circumference. Circle, circumference. The circumference of a circle is equal to pi times its diameter, or pi times twice its radius. All right, let's see if we can make sense of this. If that doesn't make sense, please read it over carefully. But what it's saying is that the circle is 3.14 times its diameter, times the distance across, or 3.14 times twice the radius. Well, we know twice the radius is the diameter. Okay. Symbols. Circumference is pi. Okay. Circumference is pi times the diameter. Right? 3.14 times whatever the diameter is. Or circumference is 2 times the radius times pi. Now, commutative property of multiplication applies here, so it doesn't matter what order we do it in. We could do 2 times radius times pi, or 2 times pi times radius. It'll equal the same. Okay, so we've discussed the relationship between diameter and the circumference. We've said that if you take the circumference of a circle and you divide it by about 3, you're going to get the diameter. Or if you know the diameter, you multiply it by about 3, you're going to get about the distance of the circumference. So circumference divided by diameter is about 3. The exact ratio is represented by the Greek letter pi, Pi. The value of pi is 3.1415926, and it's actually an irrational number. Okay, it goes on forever with no pattern, no repeating decimals. The decimal never ends, but it is often approximated or rounded to the 100th place of 3.14. Another approximation for pi is 22 divided by 7. But we know that 22 divided by 7 cannot happen unless you get a decimal. 21 divided by 7 is 3. 22 divided by 7 is 3.3 bar notation, right? Use this value when the radius or diameter is a multiple of 7. This will give you a more exact number, by the way. Or has a multiple of 7 in its numerator if the radius is a fraction. Again, if you ever see that the value of the radius or the diameter is a multiple of 7, so 7, 14, 21, 28, 35, and so on, or has a multiple of 7 in its numerator, the top number, if the radius is a fraction. So if the top number or the whole number itself is a multiple of 7, use this pi instead for a more precise answer. So here is an example where the radius or diameter or any other number is a multiple of 7. Find the circumference. Oh, we're looking for the circumference of a circle with the radius of 21. The circumference of a circle with a radius of 21. So since 21 is a multiple of 7, right? 7, 14, 21, it's 7 times 3, right here. Use 22 over 7 for your pi. And remember, to find the circumference by given the radius, we have to use this formula. Circumference is double the radius times pi, correct? So we replace it then. Circumference is times 2, replace pi with 22 over 7 times 21, our radius, our given radius. They told us radius. And now we're just multiplying fractions as we've done. We do our cross-referencing where we have 3 and 1. So now we have 1 along the bottom, and it's 22 times 3. Okay? 22 times 3 is 66, and 66 times 2 is 132. The circumference of the circle is about 132 inches. If you feel like we're going too fast, remember you can always watch the video again. Maybe you can just watch the last 4 minutes of the video to really understand this part. If you think you got it now, pause the video and go ahead and complete these by using the 22/7 for pi, because 70 is a multiple of 7, 7 times 10. And remember, if the multiple in the numerator is a multiple of 7, if the number is a multiple of 7, then you can also use the 22/7. So go ahead and find the circumference for E and F. Pause now. Okay, let's take a look at the first one together, and let's not forget the formula. Now the formula is pretty much a statement that you have to make in your head. Rather than memorizing it, just remember that we're looking for circumference. So let's just write the word circumference. What is circumference? Circumference is the diameter times pi. Right? That's essentially what it is. Diameter times pi. It's the diameter times 3.14. Now we're not going to use 3.14. We're going to use the, because we have a multiple of 7, so we're going to use our 70 for diameter times 22/7. Okay, remember now we're multiplying fractions. So we do as we've always done when we multiply fractions and we put the whole number over 1. We do our cross-referencing, okay, where we cross-reference like multiples, and 7 and 70. Here's why this works so well. It's going to cross-reference where we have only 1 here and 10 here, right? And now we really have 10 times 22. So when you multiply by base 10, you simply just add a 0. So 22 times 10 is 220. Circumference equals 220 inches. Don't forget our units. You see the inches right there? Okay, let's look at F. Again, let's make the statement. The circumference is, when given the radius, is 2 times the radius times pi. We have to double the radius to make it a diameter. Don't forget, right? We have to double it to make it diameter times pi. Now, I know that we were shown that it's 2 times pi times radius, but don't forget that commutative property of multiplication states that the order does not matter. It will all give you the same product. So let's replace our variables. And we have our radius, which is 7/8 of a foot, 7/8 of a foot, and then our pi, 22/7, right? For multiples of 7. Okay, let's cross-reference. Cross-referencing, I have 1/7 there, and I have 1/7 there, right? The 8 and the 22 right here, the 8 and the 22 are both multiples of 2. How many 2's do I have here? Well, there I have 4, don't I? I have 4 there. And here, how many do I have? I have 11. There we go. So now we can multiply straight across. I know it's starting to get a little messy, but we have our 1 and our 11 here. So 1 times 11 is 11, right? It's 11 right here. Technically, I shouldn't put 2 equal signs in one line, but it's just to simplify and clean this up a little bit. And then we multiply the bottom. 4 times 1 is 4. Okay? So that's what my next line will be. So as I begin to write my next line, I have circumference equals 2. So circumference equals 2 times. So let's go ahead and write our times. We've simplified all of this here in the middle to simply 11/4. Right there. That's why we did that quickly over there. Now we can cross-reference again, right? The 2 and the 4. I have 1 here, and what do I have here? 2 there. Okay, now it turns out that circumference equals 11/2, but this is an improper fraction. Let's change it to a mixed number. So we have circumference equals, how many 2's are in 11? 5, right? 2, 4, 6, 8, 10. So 5. And that gets me to 10, but that means I have 1 left over to get to 11, so I put my 1 or 2. So our circumference is 5.5 feet. Our distance around the circle, right there. Our distance around the circle, not that circle, but this circle right here. Our distance around this circle is 5.5 feet. Let's apply what we've learned to a real-world example. Big Ben, this clock right here, is a famous clock tower in London, England. The diameter of the clock face is 23 feet. Holy moly. From one side, the diameter, remember the diameter means the distance across a circle. From one side all the way to the other side, right down the middle, is 23 feet. Find the circumference of the clock face. Round to the nearest tenth, so the nearest first decimal place. So the diameter 23 feet times pi is going to give us the circumference. And there it is. What is our circumference? Our circumference is the diameter times pi. We know that pi is 3.14 times 23. Notice that 23 is not a multiple of 7. That's why we didn't use the 22 over 7. Okay. And what is it? Well, when we multiply those two numbers, we get 72.2 feet. Notice how we don't include the unit in our answer, but on our statement, a word question, word problem, gets answered with the word statement. So, or therefore, the distance around the clock is about 72.2 feet. And we always have to say about, everybody, because remember, we are rounding the pi to the nearest hundredth, and pi is an infinite number. So it's always going to be about. And finally, our last question. A circular fence is being placed to surround a tree. Okay, so we're going to build a nice little circular fence around a tree. The diameter of the fence, the distance across, is 4 feet. How much fencing is used? Use 3.14 for pi. Round to the nearest tenth if necessary. Okay, we're trying to find the circumference, right, everybody? So circumference equals diameter times pi, right? Circumference equals, our diameter is 4 times 3.14. So it's going to be just slightly over 12, because 4 times 3 is 12. And finally, our circumference, I'm going to continue over here, everybody on the side. Circumference equal 12.56. Now we went to the hundredth. They want us to round to the nearest tenth. This is our 10th place. It's the first decimal place, 10th. This is over 5. So rounding rule states that the number has to be rounded up to 12.6 what? Feet, right? And our therefore statement would be, therefore, how much fencing would we need? Therefore, we would need about 12.6 feet of fencing. That would be a good therefore statement. And here's our guided practice for next class. Take a look and make sure that you feel comfortable with the content. If you feel that you get to a question and you do not understand it, feel free to go back to examples 1 to 2 or to examples 3 to 4. But please do not complete this. Just have a look at it, and we will complete it first thing in class. See you then.